Okay, so the first question I asked you to do is number 10 on page 94. Even though you don't know it, you already did number 11 because it was number 2 on the sheet I gave you. It's the same as number 11. So number 10 says, from a lookout point, a hiker sees a small lake ahead of her. In order to get around it, she walks 4.5 kilometers in a straight line towards the end of the lake, and then she turns right, making a 60-degree angle with her original path. So it shows you a picture in the text, but you cannot assume that's drawn to scale. Okay? And how did I have this the other day that it wasn't following? There, maybe like that. So it says she walks 4.5 kilometers in a straight path. So you might want to do, oops, I need graph paper. There we go. So you might want to do, like make that straight path a straight line, right? So number 10. And she's going to go, like, so if I said it's 4, and so maybe 2 centimeters equals 1 kilometer. Okay? And so then I would make my straight path. I got a ruler that has weird numbers on it. 4.5, so it would be 9. Drop it down here. So starting right on this edge and going up to 9. And this is 4.5 kilometers. Okay, you may as well draw it like due north. It doesn't tell you the direction. And then it says, and if you look at the picture, it shows you where the 60 is. It's 60 degrees with respect to the path she was following. So line your protractor up and do a 60 here. So they're not giving us north, south, east, west, and this was why I didn't assign this one yesterday. Okay, and this time she's going 6.4 kilometers. So for me, that would be 12.8. So it's going to be all the way down here. Okay, oops, off the page, but honest, it's there. 12.8. And so then my resultant will be here, starting where the first one started and ending where the last one ends. Okay, and now if I measure it, I get 11.5. Oops, forgot to label this one. This was 6.4 kilometers, and this was 60 degrees. So I get 11.5 centimeters. So going backwards, you would divide that by 2 and find out that it's 5.75 kilometers. And now we can measure the angle, and you should measure it with respect to the direction she was going, because we don't really know what that direction is, but that's how they told us to turn. So we would do the same thing, and I get 75 degrees. Okay, so it would be at, oops, wrong color, at an angle of 75 degrees with respect to WRT, with respect to original, meaning original direction. Okay? Determine her displacement. So that's it. No east, south, north, west, because they didn't tell us this time. Okay, so now flip the page over to 502, and I asked you to do numbers 17, 18, and 20, because we had done 19, and for some of you we finished it, some of you we didn't. So I'll do it right at the end of the video, and that way if those of you that finished it don't have to watch. A hand glider, so 17, a hand glider launches herself from a high cliff and drifts 6 kilometers south. The wind begins to blow from the southeast, which pushes her 4 kilometers northwest. Okay, so 6 and then 4. So again, you could use 2 centimeters equals 1 kilometer. So you're going to go southeast, south, and then northwest. So I'd probably start like here and go south. I know I said 1 to 2, but I'm going to run out of paper if I do that. And then from this, it says northwest, and it doesn't tell us the angle. Whenever it says northwest, southeast, it's implying 45 degrees. So north, 45 degrees west. So line it up with your north, 45 degrees west, right in there. And this one is going to be 4 kilometers. So from the tip, 4 kilometers. Arrowhead. So where's my resultant? Starts where the first one started, ends where the last one ended. So it should be right here. Okay, measure it. And I get like 4.3. I think when I did it for real, not under the iPad, I got 4.5. So this was 6, and this was south. This was 45 degrees, and this was 4. So this angle up here should, where we're measuring, should be 42 or something like that. Okay, so it'd be square bracket. I measured off the south, 42 degrees, and I turned west. Okay? That's number 17, but it's not quite done because it says calculate her average velocity. So now average velocity takes her displacement, which we just found, and divides it by the time. So we found this to be something like, and you might have had 4.5 or 4.2, so you use whatever number you had. And then, of course, south 42 degrees west, or whatever angle you had, but it should be close to that. And then it says 45 minutes. So you need to change it to hours since we're in kilometers here. So that's 3/4 of an hour, or 0.75. So then you would do 43 divided by 0.75. And if you use the numbers I have, and yours will be a little bit different perhaps, you get something around 57.3, for me, 0.3 repeating, kilometers per hour. And then the direction is the same. So the direction of the displacement and of the velocity are always the same. Okay, I'm going to flip my page over. So number 18, and we're going to run out of time on this one probably. Number 18 says, a light airplane leaves Shelburne, flies 196 kilometers north, 15 degrees west, 195, sorry, and then 149. That's pretty, I'd probably do 1 equals 25. 1 centimeter equals 25 kilometers, okay? Just because they're both pretty close to even there. 1 to 50 will be too tiny, I think. So you're going northwest, and then you're going northeast. So you best start south. Okay, so start down here somewhere. 1 to 25, so 195 is going to be really close to 8. It's going to be 7.8, and the angle is north 15 degrees west. So line your protractor up with your east-west. I need to balance my thing again. And then north 15 degrees west. Whoops, I better shift pens. This one's finer. Will be like here. And it's going to be, I'm going to run out of space room, I think. 7.8. Going to be like that. Definitely going to run out of room. Definitely. It's okay. I'm also going to run out of video, so when you come back on, I'll have this one fixed. And then the next one is north 33 degrees east. So you line your protractor up this way this time, and from the north, you're going to mark 33 degrees. And this one is going to be 6. Okay, so I'm just going to back this up. I'll see you in a moment, and I'll have this one fixed, okay?